Okay, we're recording. So the two new pieces of information that you would need to know for tomorrow's test, we need to know, well, three, I suppose technically. We need to be able to handle Riemann sums. We should be able to handle integration, and we should also be able to handle integration by U substitution. So these are the three new pieces that would be added to this test. So when we're saying Riemann sums, we have three types that we've studied: left, right, trapezoidal. Left and right, we know how to do the area of a rectangle. If you are doing trapezoidal, your formula for that area is add up the bases, cut it in half, times the height. And as a reminder, when you're looking at a trapezoid, that this is base one, this is base two, and this is the height. Remember, I told you to kind of turn your head sideways so that those pieces make sense the way you look at them. So the three pieces are base one, base two, and the height. And when we're doing a Riemann sum, your goal is to get to the place where we just have a table of values. So if you have a table of values given, that's the easiest way to tackle a Riemann sum. If you don't have a table of values given, then you want to plug in and find them as quick as you can and make your own table. So we're going to make an XY table. F of X is the same thing as Y. And then let's just say that the table is provided for you. So give me 1 sec. We'll make something up. Okay, so let's say that's our table. So the first thing you want to do is be able to look at this and say, how many shapes are we going to be working with here? And that's going to be from 0 to 2 is a shape, from 2 to 5 is a shape, and from 5 to 10 is a shape. So this table allows you to work with three shapes to estimate this. So we'll do all three Riemann sums. So if we were going to do a left Riemann sum, we're going to start by making three rectangles. And then the width of the rectangle is determined by the x values. So from 0 to 2 is 2, 2 to 5 is 3, and 5 to 10 is a width of 5. And since it's a left Riemann sum, we were going to start from the left side of the table. So that's 1, 3, 4. And then we can use that to find these areas. So that is an area of 2. 3 by 3 is 9. And then that is going to be 20. And when you add these up, that would be 31. If we're doing a right Riemann sum, we're going to do the same thing. The widths aren't going to change any. This is still 2, 3, 5. But for a right Riemann sum, we want to start from the right side of the table. So that's going to be 6, 4, 3, and then you would find your areas accordingly. So that's going to be 6, 12, 30. So that's going to be what, 48. And then if we're doing a trapezoidal, we're going to make three trapezoids. And the widths on the bottom, which are now considered the quote unquote heights, they're still going to be 2, 3, 5. But now when we go to use the side lengths, you kind of have to picture these all touching, and we care about both sides. So this is 1, 3, 3, 4, 4, 6. And then we need to go through and find these areas using the formula for the area of a trapezoid. So add up the bases, that would be 4. Cut it in half is 2. Then times the height is 2. So that's going to take us back to 4. Over here, this would be 7. Cut 7 in half is 7 over 2. Times 3 is 21 over 2. This would be 10. Cut 10 in half is 5. And then 5 times the height, that's going to be 25. So when we add these up, I'm going to look at this as 4 and 25 because these are solid numbers. So that's 29. So I'm going to be saying 29 plus 21 over 2. To convert that, we should make that what, 58 over 2. So if that's 58 over 2 plus 21 over 2, that's coming out to be 79 over 2, or also known as what, 39.5, I believe that would be. So either version of that would be equivalent and you'd give you credit. Do we have any questions there, guys, on anything involving a Riemann sum? You are given a table, or if not, you make a table, and then you should be able to produce either a left, a right, or a trapezoidal estimate. Does anybody in chat have any questions on that?
For the how did you get that for
This one right here.
Yeah.
So we add up the bases. 1 plus 3 is 4. Cut it in half becomes 2, but then times the height takes us back to 4.
Oh yeah, I did the arithmetic wrong. Yeah, thank you.
Will there be also this in like terms of graphs on the test?
So you never have to graph a Riemann sum. I just teach it to you that way originally because I want you to understand, like the way that I'm doing this here, I don't think necessarily explains the lesson particularly great. But once you understand what you're finding, this gets you there 10 times quicker. So this is the way I want you to do it on the AP exam just for time purposes. But when I teach it to you originally, I want you to understand what this represents, which is, hey, here's a graph. We're going to break this into n number of shapes. And then this kind of gives you the visual that these shapes represent, whether it's an overestimate or an underestimate and stuff like that. But once you're cool with what this means, then this just gets you there way quicker.
Okay, got it. Thank you.
Okay, so then let's jump into integration a little bit. So I believe I used something that looked like this. So if we say 2x on 0 to 4, that graph would look like this. And we're going from 0 to 4. So if you plug 4 into that, that would take you to 8. And we said that the area of this actual triangle would be 16 because we know the area of a triangle. And then we said, well, how do we actually do that? And we said, well, there's this thing called integration. And if you integrate from 0 to 4 for 2x, then we learned some notation. We're going to learn more about this later, but all integrals have a dx or a dy or a du or a d, whatever variable you're working with, that we needed to know a rule. And the integration power rule said, if you're integrating x to the power turns into x to the power plus 1 over the same power plus 1. So in other words, add 1 to the power and divide by the new power. And this is called an integral. And if you remember in class, we said integral starts with an I, and when you integrate, you increase the power. So integral starts with an I, and when we integrate, we increase the power by 1. Another explanation of what the integral means is we want to make sure we're comfortable with the integral of f prime is equal to f of x, technically plus c. But the big thing is f prime goes to f. So these are our two main thought processes right now, is that when you integrate, we're going to add 1 to the power and divide by the new power. And the result of the integral is the original function. Integrating is sending you backwards in time. So if you integrate f prime, you come up with f, and then plus c, because technically any number, if you take its derivative, it would disappear. So this stands for all of the constants. Okay, so up to here, hopefully then it would make sense to say that this would be x squared. So how am I coming up with that? It would be x squared over 2. If we add 1 to the power and divide by the power, but you have a 2 out front, so those 2's would cancel. So that takes us to x squared from 0 to 4. How do we evaluate this? It's plug in the top bound minus plug in the bottom bound. And then this is giving you that 16 answer that we were looking for. So in summary, to integrate something that's pretty basic, you add 1 to the power, divide by the new power. If there's no bounds given, you tack on plus C. If there are bounds given, we evaluate by plug in the top minus plug in the bottom. Does anybody have any questions on that?
Just how you did the actual problem. Did you just, so the 2 out front is just the coefficient and you just basically focus on X when you did the power?
Yes.
Okay, got it.
Okay, let's look at some other scenarios that you should be familiar with. So some things we talked about in class was if you want to integrate trig, for example, there's no real good rule for trig. You want to be, when you're doing trig, you want to be saying in your mind, the integral of f prime is equal to f, and we want to answer that question. So whatever I put here, I want to be able to take its derivative to land back there. So hopefully sine x plus c would make sense. Anything that appears on the test that is trig-like, you should be able to just either look at it and give it an answer, or you might have to do u substitution if it's more complicated, which we'll get into that in a second. If I tell you 1 over x dx, that was a special case. Now, you might be thinking to yourself that that was x to the -1, but remember, we can't do that because when you add 1 to the power and divide by the power, that becomes undefined. So this one was a special case, and that's when we came up with natural log absolute value x plus c. So always remember 1 over x, you should definitely memorize these. They come up a ton on the AP exam. 1 over x, 1 over y, 1 over u. When there's no exponent involved and it's just x, just y, just u, these are all natural log. Does anyone have any questions on those?
So for natural log, yeah, so what if there's a number besides 1 on top? Could that
Sure.
also?
So if you had 5 over x dx, 2 ways of thinking of this. You could, remember from the u substitution lesson, you can take constants out. So technically, this is 5 times 1 over x. So you're allowed to just say it's a 5 out front, that's a constant, times 1 over x. And that's 5 natural log absolute value of x. And we can check this because if this is my answer, the derivative of my answer better be the thing I started with. So the derivative of 5 ln x is 5. And then what's the natural log piece? The derivative of my stuff over my stuff. So that's giving you that 5 over x part. So if it's a 5 over x, a 7 over x, you can just take that number out front, and then it still turns into ln x.
Thank you.
Okay, how about if we have a term on the bottom, but it looks something like this? If we said x squared plus x over x to the third. All right, so if it's just a singular term on the bottom, this is the one where I said your thought bubble process should be a plus b over c is really equal to a over c plus b over c, and you can take these and rip them apart. So you want to be thinking of this as x squared over x to the third plus x over x to the third. And then we're going to simplify each piece. So if you have 2 x's on the top and 3 on the bottom, to do some canceling, that's really just 1 over x. And on this side, this would be 1 over x squared. So the next step is hopefully you look at the first one and go, yep, I know how to do that. We just talked about that. And anything that has an exponent involved, we have to flip that upstairs. So I'm going to keep that as 1 over x. plus, and then this is x to the -2. So that when you integrate, first piece, we know the answer, that's natural log. And second piece, when you integrate that, add 1 to the power, divide by the new power. And then we just want to clean this up a little bit. So this would be natural log. And then take a look at this. The overall value of this fraction is negative. And I want to flip this thing downstairs. So if I run out of terms up top, we just toss a 1. And then this right here at the bottom would be my final answer to that.
Can you move your screen down a little bit to see the last part? Thank you.
That pretty much covers the basic integration package that we talked about, the trig stuff, natural log, splitting things up. You can plug, going back into this, make sure you plug in values to whatever we do. What else here? We could do this with, we could do it with radicals. So make sure that if you see a radical on the test and you're integrating, for example, if you had the square root of x from 1 to 4, so we would be rewriting that as x to the half dx from 1 to 4, so that when you integrate that, that would be x to the 3/2 over 3/2. And that is what? If you divide by a fraction, you multiply by the reciprocal. And then we want to plug our stuff in. So it's going to be 2/3, 4 to the 3/2 minus 2/3, 1 to the 3/2. So what does that give us now? Square root of 4 is 2, 2 to the 3rd is 8. That would be 16 over 3 minus 2 over 3 would give us an answer of 14 over 3. Same thing with the cube root, we would make it the 1/3 power and so on. Last call, any questions on easier integration before we jump into U substitution?
For E, is it just E to something equals E to
Well, if it's e to the x, if it's just e to the x, we're going to get e to the x. But if it's more up there, that becomes U substitution.
Okay, got it. So if it was like E, if it was anything more than E to the sum,
Yeah, so if it's like e to the 3x, anytime it's more than x. So the 4 main situations that we're looking at, it's just like chain rule in reverse. It can be things in parentheses. It can be the stuff under the square root. It can be trig, the stuff in the parentheses there. It can be the thing that e is raised to. And technically, we're not there yet, but it can also be the composite piece that's inside of there. That's definitely not on your test yet. We haven't talked about number 5. These first 4 are all fair game tomorrow, though. If the stuff in parentheses, the radical, the trig angle, or e, if any of those are more than x, we're looking at a rule. So if you had e to the 3x, for example, we would start with our U substitution. So that's U du dx, and that goes in our box. So U would be 3x. So du would be 3 dx. So dx would be du over 3. And then we go and plug in, and that's e to the u du over 3. So we're going to bring our 3 out front. That's 1/3 integral e to the u du. And when you integrate e to the u, that's just like e to the x. That'll work. If it's just a variable, you're in good shape. So that's 1/3 e to the u plus c, which is 1/3 e to the 3x plus c when I plug in. And then you can always check if you want. You should be able to take the derivative of this answer and come back to where you started. Does that make sense?
Yep, that makes sense. Thank you.
Okay, so that is U substitution. You can just do it with a whole bunch of different scenarios. So if you're integrating, x squared, and we've got x to the third plus 5 to the 10th, something like that. So I'm seeing stuff in parentheses. It's more than x. We've got a big mess. Another thing with U substitution is the stuff in parentheses and stuff is always going to be 1 power greater than the stuff outside, because that sets up a cancel situation. So this is going to be U du dx. So U is going to be x to the third plus 5. So this is 3x squared dx. So this is going to be dx is du over 3x squared. So that's x squared u to the 10th du over 3x squared. Those are going to cancel. I see 1/3 coming out front. We've got u to the 10th du. Now we're ready to integrate. So that is 1/3 u to the 11 over 11 plus c, which is going to be, plug in for u, x to the third plus 5 to the 11 over 33 plus c, 33 coming from 3 times 11. Okay, if we had something with some trig, how about if we had e, let's see, to the sine x over secant x. So we're looking at this and saying, all right, what do we got going on here? We need to do u substitution. So u du dx. So this would be u is sine x. Remember, it's not e to the sine x, it's just the thing that it's raised to. Du would then be cosine x dx. So then dx would be du over cosine x. Okay, so we start to plug in, and this would be e to the u over secant x du over cosine x. And then we need to know some properties with trig. Secant and cosine are reciprocals. And if two things are reciprocals, they cancel out. So that means those cancel. And now you've just got e to the u du. And that would integrate to be e to the u plus c. So that would be e to the sine x plus c. And then if you had bounds involved instead of plus c, you would plug those in. In terms of new material that we covered, guys, that pretty much hits it. That's Riemann sums, intro to integration, and U substitution. You have the study guide that's on Canvas that kind of shows you the rest of the stuff. You know what else will be on there. Do you have any questions for me or anything you would like me to do?
So when you're integrating plain numbers, is it just the number and then an x? So like if it's like if you're integrating like, I don't know, 3 or something.
Sure. If you're deriving 3, whatever that number is, that's just going to be 3x plus c, or 3 plug in 3x and plug in your bounds. So because if you take the derivative of this answer, that takes you back to 3. So in general, the integral of any number, just a constant, 1, 2, 3, 4, 5, whatever, is that number x plus c.
Thank you so much.
Mm-hmm.
I have a question about one of the study guide questions.
What do you got?
Question 26.
Go ahead. What is it?
It was f of x equals 2 to the 4x.
Oh, yeah, that's not on your test. So I think,
No, it's not.
was that 26 and 27? There was like 2 in a row.
Yeah,
Yeah,
26
there's
and
also
27.
Yeah, 26 and 27. You can put a skip on that. I'll teach you that next class.
All right, thanks.
Mm-hmm.
Thank you.
Anything else, guys, you want to see an explanation to?
Oh, just to make sure, was number 8 on the study guide? It was like 3x.
You can skip 8 too.
Okay, got it. Thank you.
It's a U substitution question, but that one was a little more complex. I told you guys to skip that one. The ones what you're going to see on your test is literally what we just covered over this half hour. You can skip from the study guide. You can skip 8, 26, 27.
Thank you.
Mhm. Okay, that's it. You can head on out, study a little bit more. I'll see you guys tomorrow. I will have this video uploaded in 5 or 10 minutes.
Thank
Have a
you
good
so
night.
much.
You got it. See you guys.